Hello, everyone. Welcome to part 5 of Learn Networking with Cilium. How's everyone doing today?
Doing great.
Not too
Doing
bad.
good.
Awesome, awesome. What did we do last week? We actually dug into some network policy. And I think, Dan, you weren't around, right? I think you were out
No,
at,
I was right. I arrived just, so I was like,
oh,
I was
yeah,
in a
that's
taxi
right, that's
getting
right.
quite close. Yeah.
Oh yeah, that's right. Yeah. So we actually jumped into a lot of the network policy stuff and saw some network policy in action. Today we want to dig into some troubleshooting and network, and we'll we'll actually use Hubble to understand the way we would troubleshoot, let's say Kubernetes networking and services inside of Kubernetes. But we're going to start with understanding just the methodology, the mindset. Um, Anyone's welcome to chime in and share their process. But I'll start off with a long time ago when I was studying certifications. Oops, wrong one. When I was studying for certifications, one of the things that one of the certifications I studied for was the CCNP, Cisco Certified Network Professional, and that certification actually had 3 exams. One was a route, another one was a switch, and the last one was troubleshooting. And troubleshooting is a methodology and a mindset. It's like, where do you start? And when you start, what's the process? What do you follow? What are the tools that you use? What is the data that you're recording as you're trying to deduce what is going on, right? So some of the mindset that I've always adopted is when something is broken, is it just me or is it everyone else, right? Is it widespread or is it just contained to a small little area? And that should be very telling, right? If it's everyone, then it could be something larger. It could be a massive system outage. Someone might have cut a fiber somewhere, causing the internet outage. Someone might have injected a rogue route into the internet BGP routing table and has sent the traffic to a unknown destination. A lot of different things can happen, but it's the scale, right, which would help you determine where to begin your troubleshooting. And this is applicable to a lot of different areas, not just networking too. But let's think about it from a different sense too. Okay, if someone's experiencing this, can I also experience this? How do I replicate or duplicate this issue in my own little environment so I can kind of start to begin to see what's going wrong? And then we also need to figure out what is actually broken. If someone comes to me and says the internet is broken, that's very, very broad and generic. But if someone says this little application that I'm trying to access isn't accessible, but these other ones are, now we've kind of pinpointed where that issue might be. Is it something on the client side or is it something on the server side? So when it comes to networking, it's always about finding where that break in connectivity is or where that loss of connectivity is. And there are different tools and systems that we can use out there to just really figure out and narrow it down. Let me pause for a second and say hello to everyone. Hi, Krish. Welcome to the conversation and live stream. Thank you very much. Siddhant, welcome again. Welcome. Okay, another Krish, hello. Guillaume, nice to see you here. Thanks for coming by. Kai, thanks for coming by. Prashant, hello. Good morning. All right, Dan, Aakansha, Leon, any thoughts around your mindset to troubleshooting? And Leon, I know you have a lot because you work in that space, but how about Dan? You go first.
It's interesting. It's been, I think, with the way that things have changed a lot. Now, like, networking troubleshooting is kind of more important than ever. It used to be. So, I mean, a long time ago, I did IT support where applications were specific to a particular server. So this was mid 2000s, Big Sun servers and things like that. You would buy basically one of these big boxes to run your big application on there. And in the course of the day, you'd be logging onto these boxes to potentially clear out filling file systems and stuff like that. And if you fat fingered something, then that is typically how you would break things. So you would typically break servers at that point. But now the mindset's kind of a lot different, with all distributed applications and things like that. And now the application, I would say now it's less likely for you to ever really be fiddling with the node, fiddling with the application specifically. And even if you do break a node, distributed systems and things like that mean that maybe a bit of downtime, but ideally the system is designed to kind of cope with that. So networking now that is kind of largely a thing that kind of is what holds all of those constituent parts together. And when things do break, it's there's more onus on the network than there really ever has been before.
You're absolutely right. Leon, what are your thoughts? I mean, how do you, what's your approach to troubleshooting?
So troubleshooting to me is like everyday job. So I do it like on a daily basis. Right? Network issues are always like the first, but like everything, nobody ever accepts that it's a network issue. So it takes a lot of in distributed systems. It's a bit tricky because there are too many logs, too many points where things can fail. One of my favorite enemies is slow network. So networking is fine, but slow networking is still something that causes a lot of issues in distributed systems. Things like Golang applications and all, they're like they are always configured with a context deadline, right, or slow connect. So it's always a timeout issue or something. But for me, like replicating, like you said, that is one of the most I would say important things, because if I can replicate it, then we know for sure it's a bug. But yeah, it takes a lot in distributed systems to troubleshoot.
Yeah, distributed systems, I mean, there's so many moving pieces, and every piece of that distributed system is going to require its own little networking, have its own little nuances and its own specific setup. And one of the things that we want to do is standardize on common networking so that it makes it easy to troubleshoot where things are going wrong. And for the most part, that's been achieved in multiple layers, right? Physical networking, the physical layer itself, there is some common denominator there. When we're talking about software defined networking, there is also a common denominator. Kubernetes networking, there is a common denominator there. And that's what we want to make sure that we aim to look for, because it makes it so easy to troubleshoot. 10 years ago, no, 15 years ago, when you were troubleshooting networks, you had an ASA device, a PIX device, an HPE switch, a Juniper router somewhere here in the mix, and then some random D-Link device that was sitting there propagating broadcast storms or something along those lines. And you start to think, like, where does the actual troubleshooting begin? But through the combination of knowing what went wrong, implementing a best practice, we start to see less and less of these network challenges and problems. But we've also developed, processes, tooling, and systems to be able to determine like network observability when things seem to be, saturated. For example, let's say you have a wire that might be overutilized and there's not enough available bandwidth and there's just too much going on the wire. We have tools to tell us that now, and that's like phenomenal. So let's kind of break down some of those tools that we've seen before. So Ping, for example, Ping is a fantastic utility that helps us just establish if there is connectivity to something else, right, or even to ourselves. If I wanted to validate that I could get internet access outbound, I'd ping something like Cilium.io. Cilium.io would respond and say, yeah, successful ICMP reply. But there's a lot that's going on behind the scenes. For example, Cilium.io is going to be translated into an IP address, IPv6 or IPv4, it doesn't matter. But that address means that now we have to determine how to route to it. And once we've determined how to route to it, because we're using our default gateway to get there, we now have a pathway to get to that endpoint. And so it knows about a return path, and it could tell us, hey, this is going to respond to you. Here's your answer. Now, what happens when there's a break in connectivity? And that's why we have something like traceroute, which is basically telling us all the layer 3 hops that will ICMP reply to us, and the hops in between to that endpoint, which is actually pretty important if we're trying to establish, whether we're taking an optimal route or a suboptimal route. And then there's dig, right? Dig is helpful when we're trying to establish whether or not our DNS is working. If we're DNS resolving names, if we're resolving host names to IP addresses for that matter, if we have connectivity to a DNS server for that matter, something that can resolve addresses for us. PHY, phi, what does that mean? The physical layer. When I was working in the data center, a lot of issues would also happen from a physical standpoint, meaning there could be a broken physical cable somewhere, a cable that has a clip that's not fully like that's broken, and so the actual plug or RJ45 connector is not plugged in all the way. There might be a dusty fiber, right? If it's a dusty fiber, that means like you're going to see a break in that light connectivity or that fiber optic connectivity. So there could be issues at the physical layer. There could be physical hardware failures for that matter too. Chips on your switch fail, ASICs on your switch fail, ports fail, electronics fail, right? Constant usage leads to failure. And a lot of these devices do have established, some sort of mean time to failure metric or KPI. So you could like say, they say you could run this device or this switch for X amount of years under these conditions. But there's so many different ways to assess physical failures as well, because it could be something else as well. Curl is great because you're now trying to establish the connectivity to an HTTP based application, right? So you're trying to establish if you're going to be able to pull data in using the curl utility. But at the same time, maybe there's something going on further upstream that we don't have control over. For example, you own a massive private cloud environment and everything works well. You've got private circuits all over the place. You've got a couple of exit points for internet egress, right? Meaning you might have an HQ that has an internet egress and all your traffic has to come to HQ before it gets out to the internet. And then you might have a backup site that does the same thing, that has an internet egress as well, or an entry point. Now, there might be a situation where you have, complete visibility on your network, but something on the provider side fails and you have no control over that, right? You're at this point working with your provider to establish a root cause. And now they're trying to resolve the issue. It might be a cut fiber somewhere. Someone was digging and boom, they just dug right into the fiber. And now there's like a massive like chunk taken out of that huge wire, right? And because of that, it could take anywhere from a day to 2 days to multiple days to get that repaired. And so you have to have a mitigation plan, a mitigation for your outage. And your backup plan might mean rerouting your traffic elsewhere. But again, if it's something upstream, these are things you don't have control over. And this is why you're building resiliency in multiple ways. You're building high availability into your network. So if you think about internet circuits and the way we connected outbound, we would use some sort of load balancing device to help us load balance connections. That was actually solved with this technology called SD-WAN, where they would aggregate all available internet circuits and then either fail over or allow you to use all available bandwidth. But if there was a failure, there shouldn't be a break in connectivity. So that problem's been solved. It's just if companies and organizations out there see the value in something like that and decide to use it. There's other ways to build out availability. You build it into your applications, irrespective of the network. The network fails, who cares? Well, you've got another, instance of it somewhere else that is going to respond. May not be as optimized as we want it to be, but it's still out there. Thoughts, Dan, Leon, Aakansha?
Yeah, sure. I mean, I think some of the other tools that I would look at amongst all of these as well are things like the ARP-A command. So what have we seen on the network is if something's not responding, ARP-A will actually determine even if a device even appears that looks like that on the network itself. Have we actually found a physical device that maps this IP address that's no longer working? And then additionally is looking at the routing table. So either netstat minus RN or IP space R, which will give us our default route. So if we don't have any specific routes for it, where are we sending traffic to? Or if we do have some routes in there, the routes might be wrong. We may be sending traffic to the wrong place. So those are kind of like layer 2, layer 3 areas to kind of look at, I suppose. Additionally, if you're doing things like natting and things like that, being able to grok and understand kind of IP tables, especially all of the different, kind of tables that sit within there and things like that as well. So being able to start looking through kind of all your inbound and outbound rules to work out, kind of if you are looking for the right packets, if you're sending them to the right places, things like that. And then finally, IPVS as well. So if you're doing load balancing, being able to basically kind of look at the virtual server that you've created and the backends for it and stuff like that. But IPVS is so simple and so nice. I'll give that one a free pass.
Yeah, we can come back and hit that one up maybe in a future module, because I think load balancing in itself, from a Cilium standpoint, there's a lot of different ways Cilium provides load balancing, not just the traditional service type, but there's other things that it does. So Siddhant has a question. What are physical load balancers? Do you simply configure a router or switch in a particular way? So Siddhant, way before Kubernetes existed, we actually had a device, a physical appliance that acted as a load balancer. So it would accept connections and then translate that to a back end, a pool of resources. So you would use something like a virtual IP to handle incoming requests, or you could even use DNS. DNS is another way to handle this, but it would handle the incoming requests, and it would round robin or use some form of algorithm to determine which backend would be best to send this off to for processing effectively, and then which one would provide the response. So that's a still powerful concept, and it's still widely used in a lot of environments. In fact, cloud environments heavily use load balancers. There are cloud load balancers that are deployed all over. Yeah, go ahead.
Sorry, yeah, I mean, like F5, the massive company F5, like
Exactly.
They make these huge devices. You log into them, you basically say, right, I want this IP address, and then I have a bunch of backends that sit underneath them. And the F5 will do things like health checks on, say you have, like, you've got your virtual IP, it's exposed to a web server, and then you put your 20 web servers beneath it. That pool, it will keep that pool, but it will health check all of those backends, and it will make sure the traffic only goes to healthy ones and stuff like that. In on-prem environments, having F5 sit as your ingress, not necessarily like ingress, but just your way of getting traffic into your Kubernetes cluster is a kind of common design mechanism at the moment.
Yeah, I mean, there's the load balancing patterns are varied because there are different requirements that are going to pop up for your application needs. So there's go ahead.
One last one before we move on. BGP out of the box will load balance between connections that sit underneath it as well. So if you are advertising a number, if you're advertising the same 32 route to a number of different hosts, the router that is peering that will basically load balance. It'll round robin between all of the backend nodes that are advertising the same route as well. So you get load balancing for free from that perspective.
Yeah, I mean, that's a fascinating concept, because routing in general has its own approach to a sort of load balancing in a way, right? Through equal cost multipathing and the way you set up your routing and your administrative distances and all that stuff. Like, actually, we definitely should spend a good session on just routing alone, because there's so much we can dig into that. And I think there's like a time we could just combine this with BGP. Anyways, let's move on, and then we could get into
Marino,
some of
I
that.
have one question.
Sure. Yeah.
Like you mentioned about SD-WAN, so like what's that? I'm not aware.
SD-WAN. Yeah, SD-WAN, software-defined wide area network. So we have LANs and we have wide area networks, right? LANs are local entities, which subnets. We can have multiple subnets, and then when we want to connect to remote networks, we'll use a WAN. Or we'll use multiple WAN connections. So it's basically across the global internet, or it could be a private circuit across the globe. SD-WAN, right, software-defined WAN, just is a mechanism that uses concepts like IPsec VPNs and some automation and certificate or passkey management, and then also some policy management to create an aggregation of circuits so that they could have a virtual wire. So that, let's say, for example, when you look at virtualization, in virtualization, you have multiple hosts, right? If you lose a host, no one cares because you still have a pool of resources. The same applies with WAN circuits or internet circuits. You have multiple circuits that are logically grouped together. If you ripped a circuit away, the application doesn't even know that the circuit was ripped away because it's going on top of a virtual wire versus a physical wire. But there's a lot of fancy tricks that happen behind the scenes, like how packets are duplicated, compressed, and whatnot to be able to achieve like increased bandwidth and whatnot. In a nutshell, it's like automated VPN tunneling, which has been sold for a while and still is something of a solution that's available widely today. Anyways, any other questions about that?
No, that clears me. Yeah.
All right. So there's a lot of different kinds of tools that we can use. I'm bringing up 4. We'll see another one shortly through Dan's screen share. But in order to troubleshoot a network, sometimes we want to troubleshoot a flow, right? Can point A talk to point B, and what's going on, and can we, debug and decipher that communication stream? And so we'll use a tool like Wireshark, which actually does exactly that. It sniffs traffic on a particular stack, TCP/IP stack on a wire, and then just captures all the traffic that comes through, right? It captures the source destination information, payload information, whether it's encrypted or unencrypted. It captures MAC address information. It captures any sort of protocol information that would be present in every single packet and frame that comes through. Now, when you have a stream of this, like a full stream, you're now able to replay a lot of that data and understand the flow of the traffic, the source destination, and the actual payload. Like, what is the data? What is the application? What's actually going on here? And that's usually great for debugging network connectivity issues or breaking connections, or maybe something that might be preventing a communication from happening, like a firewall, for example. So Wireshark is like a more Windows-friendly version of this, but TCP dump is a very similar approach where you would run this in Linux, which is effectively something that is eBPF related, if I'm not mistaken, right? Or it's BPF related.
Yeah, I believe TCP dump is BPF related, but effectively it connects to an interface and just duplicates the contents of every packet and basically writes it to userland where userland can do what it wants to it. We can actually do a quick demo of both of these tools as well, if you'd like, as well, just to kind of step people through what they look like.
Yeah. I don't have anything, but if you have something right now, that'd be great. We could show it in a second. But let me talk about KubeShark, which is just a Kubernetes version of Wireshark, which you run in Kubernetes to understand network connectivity between your pods and whatnot. And it kind of gives you a PCAP dump as well. And then there's something called Kiali, right? If you're familiar with service meshes and you're very familiar with HTTP requests. So in layer 3, layer 4 networking, we're talking about IP addresses and host names that communicate amongst each other. In layer 7, we're also talking about host names and services that communicate with each other and make requests. But behind the scenes, there is a DNS translation that happens to an IP anyways. Now, what Kiali is actually helping us with is, from the application or service layer standpoint, what services are communicating with each other and how often are they communicating with each other? Meaning, how many HTTP requests are going on, or how many layer 7 style requests are going on in the form of service calls. Because what's going on here is you have an entry point, which is in service mesh, a gateway, right? Whether it's Cilium or Istio, doesn't really matter. But we're using this entry point to connect into a service. Now, that service is not the final destination. That service actually needs to communicate with other services in a request path to be able to provide an output to whoever is requesting some sort of output. So Kiali is just a tool to visualize the service request path, or in another way, to also visualize the pods in this request path to give us an output. So it's another form of network troubleshooting. You may or may not encounter it, but I'll stop there and I'm going to pass it to Dan to show us some stuff at the terminal. Any questions or any other comments? Nope, nothing cool. Hi, Mystica. Thank you for coming. And hi, Rahul. Welcome to the conversation. And Guillaume, for sure, we will go back and cover off load balancing and some routing later on in a future session.
Just to add, like apart from CubeShark, there's also this one tool called KSniff. So it's similar to CubeShark, but it's more like local. So it just deploys like a pod, and you can get like a stream to Wireshark directly. So even that was like a good tool. I had done like a small talk on it, but it's a pretty good tool with CubeShark, because CubeShark is like a bit limited, but it's like a UI and all with it. But KSniff like directly streams to Wireshark.
How do you make sense of TCP dump? I've not really seen how to use it with the flags. Well, the best way to make sense of TCP dump is to either, Dan right here is the expert, or I mean, you could also ask ChatGPT to spit out some flags and give you some guidance on how to use. Because honestly, I think at this point it's well tuned to understand a Linux kernel and know the different flags in TCP dump. So it's pretty useful if you just specify. And most of the time, it's just prompt engineering at this point.
Yeah.
And then, so that said, mainly TCP dump, grep something. Yep, sounds about right. Grepping an IP or a particular port or something like that.
Yep.
I just take the TCP dump and like just push it in Wireshark. So
That's
it's like a
exactly what
UI.
I'm about to
Yeah.
do.
Let's
So
go.
yeah, so I mean, this is basically BGP under WireGuard. So effectively, all I've done here is run the command TCP dump -I for the interface, TCP port 179. So that's the BGP port, and then the final bit is -W BGP.cap or PCAP or whatever you want to call it. So what effectively that has done is it's told TCP dump to bind to the interface, and any traffic it sees going in or out actually of port 179, it will capture all of that. So if we look at, we have a full sequence. It's captured every packet until I stopped it, going back and forth. So we get everything that's actually happening from a TCP perspective. And if we start at the third line here, 1 and 2 are something else that are accidentally captured. But you can see there's a little line down the left-hand side, which actually captures the beginning of all of the communication. So it's understood that if we look at sequence number 3, from my machine.22 to my router, a TCP SYN was sent. Number 4 is the SYN ACK back. 5 is the ACK in the opposite direction, which effectively means I'd like to communicate. That's fantastic. I also agree. Now let's start communicating, because this is the handshake that happens in TCP. Once we've done that handshake, so those first 3 packets have gone backwards and forwards, from packet 6, we can see we've actually got some BGP traffic actually happening. So TCP's done its handshake. Now applications are doing that. That TCP handshake you would see for all, if you're doing HTTP, for instance, you would see those same 3 packets, always those same 3 packets, the SYN, the SYN-ACK, the ACK, etc. every time. That's the dance that has to happen. But one of the really good things, so if you use TCP dump on its own, there's going to be a lot of data to try and understand in the terminal. Sometimes having GUIs is helpful, and especially Wireshark, it actually understands application data to a certain degree as well. So, for instance, SIP traffic. Here we can see down here, it's understood that this is the BGP protocol. So we have the full. This is the full contents of the packet, and this last 61 bytes is BGP data. And it can understand all of that. So it understands that this is a BGP open message, which is going to start the BGP peering. Here's who's doing it. Here's who's starting the peering. So that's my local machine that's sending that to the top of rack switch. Further down, we can see here, we've done the open, we've done the keep alive. So this is effectively everything that's required from BGP. We're now advertising routes and things like that. And yeah, there's a lot of reasons why this is useful. One, we can understand application data. We can sit in the middle here. So if we're starting to see wrong routes, we'd be able to see what the application is actually sending. So we'd be able to determine kind of where the problem actually is happening. And also in some circumstances, we talked a little bit about the old handshake here. So we've got SYN and SYN-ACK and ACK, etc. This big red line here is a reset. And this can happen in certain circumstances where firewalls or whatever it is that may sit within the data path causes TCP causes TCP resets. And when a TCP reset occurs, a connection is immediately shut down. So there's a lot of reasons why we may need to look at kind of all of this kind of deep underlying information to actually determine why networks are not behaving as expected. Is it the network that's not behaving? Is there something wrong in the TCP path that's not even setting up the session itself? Or do we need to drill down into the application itself, see what the application is sending, what are the responses, etc., and things like that? And this is really what WireGuard is fantastic for. In a lot of cases in network debugging, these PCAP files are effectively emailed back and forth for somebody then to basically review through Wireshark to try and determine what's actually occurring under the covers. I suppose one other thing this weekend I heard of was a tool called EdgeShark, which is Kubernetes aware. So it works with Kind and a bunch of other stuff as well. I was hoping I'd get a little bit more time to play with it, but unfortunately I didn't get chance to set that up.
That's pretty awesome. I'd love to check that out. Maybe we could explore that. Yeah, we'll explore that in the future.
So yeah, that's kind of WireGuard. But there's also a web browser version of it as well. So you can upload your PCAPs to a web version of it, and it'll do all of that processing and stuff like that as well. So a very useful tool in the network armory of debugging things.
Yeah, I mean, I agree. I do recommend folks get familiar with both TCP dump and Wireshark if they're deep into the networking space or they really want to accelerate their networking journey, because the more and more you see PCAPs, you'll better understand how protocols work, and as well as how the communication streams are formed as well. Do you want to also show folks Hubble and how it provides its
Sure, yeah.
connectivity?
So
Awesome.
let me.
I think Hubble is part of Cilium, but is also kind of an external add-on component. Is that right?
Yes. So let me just click this share button, and then we'll go through it. Right. So this is the Hubble UI with nothing actually occurring in it. Cool.
Yeah.
So what is Hubble to begin with? So Cilium, there's actually a couple of sub projects that have grown from the Cilium project, and they've basically grown out of the fact that as we've developed, as the amazing engineers that have created Cilium, standing on the shoulders of giants there, have done all of that clever networking, they've been able to effectively realize that we have access to all of this low-lying packet infrastructure information. We can kind of infer what's actually happening here and things like that. Why don't we take that information, then present it to the users, either for observability reasons or for control reasons or for debugging reasons and things like that. And Hubble is something that you can effectively just turn on. So it's quite simple to actually do. So under most circumstances, you'll bring up a Kubernetes cluster. You'll do a Cilium install. That will stand up your Cilium CNI, and all of your networking magic will now work. And then it's just a case of, let me just get the correct, which window was I using? So bear with me. Here we go. So it is a case of running the command Cilium Hubble enable --UI if you want the UI. So yes, Cilium Hubble enable will effectively just turn on Hubble. And that now means we effectively have some additional services that are running within that Kubernetes cluster, which are now taking information from your from everything that the CNI is actually doing, and then can present that. So we've got the UI up at the moment. I've not hit anything, so it's not actually generating anything. In this other terminal window right now, I'll just do a quick curl, which should start to generate some actual information. So we can see here, I've effectively curled the Death Star service. So StreamYard is being very helpful. I can see myself presenting, but I can't actually see the window that I actually need to click on.
I love it. Yeah, we definitely need to navigate StreamYard. It's interesting, but are you able to? Yeah, okay.
I have. I've found it. Cool. Right. So just that one curl command has suddenly generated all of this kind of information that we can start to see within the actual UI. So we can see inside the default namespace, so it's namespace aware and things like that. The X-Wing pod, the X-Wing pod has connected to two other pods within the Kubernetes cluster. So first off, inside the X-Wing pod, I curled Death Star. So first off, we'll have gone to the kube DNS pod in order to do that DNS request, which is why we can see port 53 UDP. And then after that, it will have done the actual HTTP request to the Death Star instance. We can see here everything that is specific to that. So we get all of the selectors, the namespaces, and various organizations that it's aware of. Same from both sides and things like that as well. So we can get a complete overview of that service. Now, this is very easy when we've basically just got one pod talking to another. But when we start to have big multi-layered applications that may have typically you'll have some front end which may comprise of one or two layers, but your middleware might be much more complex. One request might go to various backends, may do some rendering, may go speak to a database, and this, that, and the other. The fact that out of the box this will generate all of that information for you is absolutely fantastic. Additionally, as well, down at the bottom we can see these text lines here. Which are effectively, we can see it did the DNS request here. We can see, let me make that a little bit bigger. We can see the source and the destination, the actual pod ID, all of that. So we get all of that networking information that's internal to the Kubernetes cluster. So we get all those internal addresses. We also get the verdict here. The verdict means that no network. Well, the verdict is what's happened with network policies. So we have no network policies enabled in this cluster at the moment, which means that when I try to access that Death Star resource, nothing actually stopped me. Now we do the Star Wars. This isn't, Star Wars. We've never said Star Trek then. We do the Star Wars demo quite a lot. I'm probably going to get fired for saying that. We do the Star Wars demo quite a lot. And people who are not aware of this means it can be a little bit confusing. X-Wings are the goodies, and people who do Death Star are typically the bad guys in the movie Star Wars. So an X-Wing really shouldn't be going near the Death Star. So we typically will put rules in place to stop that. But there's no rules in place at the moment, so an X-Wing is successfully connected to the Death Star. So the verdict is green, it's forwarded, and things like that. If we have a little bit of time, we can quickly do one of the network policies, and we'll be able to see within here now that we can no longer do that. Those packets are actually dropped, and we'll be able to see why.
So Guillaume has a question. And it's going to cover your face. Sorry. Doesn't intercepting the traffic to log it introduce latency?
Sorry, I was just quickly copying and pasting something. Doesn't intercepting the traffic to log it. So we're not really intercepting the traffic. The traffic is transpiring whether we go through it at all. And also this is all done in eBPF. So largely this is all done in kernel space as opposed to user land. So a lot of this is actually offloaded. So a lot of this is largely things like layer 3 and layer 4 headers as well. So when we're doing lookups, really, it's IP addresses and ports and stuff like that. So in terms of how invasive this is within the data path, is absolutely minuscule. It's effectively comparing one number to another, which is as much as that's happening. And in the majority of cases, a lot of this is offloaded or pretty much runs at line rate because of what it's actually doing. So with this sort of stuff, no. When we start to do layer 7 inspection, that's when a lot more processing can kind of come in. You can't really offload a lot of layer 7 stuff because there's an endless amount of applications that may exist. So, you know, like there's no way really ever to kind of really offload that.
Was there anything else you'd want to show in your Hubble UI, or is that good?
I'll come back in a second if we have some few minutes, and I'll show the network policies as well if we have a chance.
Yeah. So I'm going to actually talk about a way I troubleshooted a network issue a long time ago, and this is more specifically on the physical side. So if you're all familiar with layer 2 and spanning tree and the way, you know, a root bridge is elected, there are a lot of different criteria around how a root bridge is elected so that certain links are blocked and others are active and forwarding traffic from a layer 2 standpoint. Well, I got into an issue one point where the intended device that I hoped it to become the root bridge wasn't the root bridge, right? So traffic was not flowing in the direction I was hoping for. It was actually unoptimized. So I was trying to figure out what this could be or why this was causing it. So I'm hopping into every single one of these devices and I'm looking at the spanning tree configuration. You know, I've got my static configuration set up from the sense of what I know the MAC address should be for the root bridge, but it's still not working, right? And then I began to realize, like, let's think about the considerations around spanning tree. And what also came into consideration was things like speed and duplex. Auto negotiation. I started to look at all the links, the physical links and their wires and their status. And I had noticed that two ends of a wire, one end was going to one switch, the other end was going to another switch, wasn't negotiating properly. It actually came down to the fact that the actual transceiver on one end was defective. So the way I found this out was, like, I had a spare transceiver. I plugged that in, and I usually carry spare transceivers when you're out in the field. You have to have like just spares just to be able to test and whatnot. I plugged that in. I couldn't use it long term because it was a slower speed 1 gig versus a 10 gig link. But I plugged it in, and because the other end could also negotiate down to 1 gig, the line came up and spanning tree reconverged, and the right switch was the root bridge. But it's something like that where you're not just thinking about configuration. A lot of other elements can come into the mix here, like the physical layer too. And a defective transceiver can cause you nightmares if you haven't even picked up on it. How did I determine that there was a transceiver issue? Well, when you actually look at the interface statistics, it pops out a wide variety of different counters. So like there are CRC errors that show up, any sort of, what do they call them? Jumbo frame, not jumbo frame. There's another term for it, giants, runts, all of these different kinds of errors you would see. And as those counters increase, it's indicative of either a wire failure or a transceiver failure. So it was, easy enough to narrow down. But this is kind of the approach of shooting from the hip, where you're picking a layer in the OSI model and you're either going down or you're going up. In my case, I started at layer 3, decided, what is working. Okay, anything above layer 3 doesn't work. Let's go down the layers, and that's how I determined, where the issue in the break was. So, Dan, do you have a story around, that, something similar?
I have many networking stories, most of them not good. It's troubleshooting networks is always kind of interesting. Things like that, things like what was the big one ages ago? It's not big TCP. Was it when all of a sudden you could have the large packet sizes, big MTUs, jumbo frames?
Yeah,
everybody's favorite thing from the mid 2000s or whatever. So all of a sudden frames could be quite big. That's great. We can get more stuff done, maybe. But it turned out that for most traffic, it didn't really make a lot of sense, because if you have jumbo frames, but you still have kind of tiny bits of information, then you're just kind of consuming more empty space and stuff like that. And that kind of broke a lot of stuff, especially in VMware clusters and stuff like that. People would half enable it in one place, but not in another place. So frames would suddenly go from being big to being made up of 6 little bits, and you'd have fragmentation all over the place. And all of that then generates CPU overhead, because the CPU needs to put these packets back together again and stuff like that. I mean, I feel like I was burnt quite badly in the mid 2010s to a certain degree, with the big push to put everything onto the network. So software-defined networks, software-defined storage that sits on those networks and things like that. I once traveled like 12 hours to go do some work with a customer. They had all these clever software-defined networks, and somebody had made a change over the weekend. That one change was propagated to everything. So the entire network was then taken down, but not just the network, the storage that sat on top of the network then also stopped working. All of the VMs that also accessed all of that storage that was on top of all of that network that had been broken was now also broken as well. So every single layer had been broken from one tiny change. And it's that's the world we've created for ourselves to a certain degree.
Yeah, you're right. I mean, the layers of abstractions have just popped up over and over and over, and it does create some network troubleshooting challenges, because now you don't know where the actual issue really is. It becomes harder because of those layers, right? So you have to decide: do you start at this highly abstracted layer, which could be at the service mesh layer, or do you dig right down to the physical layer itself? So yeah, Leon, Aakansha, any stories that you want to share? It doesn't have to be network troubleshooting. It could be any kind of troubleshooting.
Uh, I have a story every day. So troubleshooting in Kubernetes is like very irritating, especially if it's things like OpenShift and where there's like an additional layer of security, but
Mhm.
it also makes it very hard for usability.
Yeah.
So most of my days, I'm just trying to figure out what OpenShift has tried to secure, and like in terms of that, broken applications that run normally on Kubernetes. But
Mhm.
it also is like network. So like the customers that I support mostly on-prem sometimes. So networking on-prem is still a little bit of a touchy topic, since nobody like likes to accept it, like it's our network. But yeah.
Yeah. Aakansha?
I don't have any troubleshooting experience till now, but it's mostly debugging because I'm in my learning phase. But
So debugging, I'm glad you brought that up, because debugging is synonymous any technical domain you go to, whether it's in development, network troubleshooting, security troubleshooting, cloud operations. The mindset is there, right? The same mindset is there, is where you begin, the kind of notes you take, the data that you're able to extract to be able to determine and pinpoint the issue. And believe me, like, if you can troubleshoot your code, you're going to have no issues troubleshooting your network configurations and network issues. And I say that because, like, I follow patterns, right? I do patterns really well. So if I see something in code that looks similar that I can re-implement elsewhere, that is how I develop, not by like starting from scratch or something like that. And the same applies to like network configs, network errors. And what's interesting is the network issue that you faced, someone has probably faced it before. And if they haven't, it's probably a bug, just like it is in code. So, having said that, I think this is a good time to bring us to a close, unless anyone else has anything else they want to share. No? Okay, that's fine. I will be traveling next week on the Monday. So, streaming is going to be kind of challenging. If we can't do it next week, we will do it the following week, or I'll find a way to get this scheduled so Dan and Leon and whoever else can join and cover on another topic, and we'll figure that out before that happens. But if not, we will see you all soon. Thank you all for coming by and, seeing all the network troubleshooting that's been going on and, just picking up processes and a mindset. So we hope to see you all again soon. Take care. Have a great morning, evening, afternoon, wherever you are, and have a good rest of your week. Thanks, Dan, Leon, Aakansha. Take care, everyone.
Bye.